Hi there, and a warm welcome to Projex Academy's Design for Six Sigma. Now, you may be already familiar with our Lean Six Sigma Masterclass, which provides you with a method for taking existing processes, products or services and improving them. This is based on a methodology called DMAIC, standing for Design, Measure, Analyse, Improve and Control, and is there for when you want to improve existing processes. But what about when you don't have an existing process or product or service, rather you want to create one? Well, that's where DMADV comes in. I'm sorry, there's not a nice way of saying that, but you'll see that it stands for Define, Measure, Analyse, and it's the last two steps that are different, Design and Verify. And in this set, I should be providing you with an overview of Define, Measure, Analyse, Design and Verify. So by way of comparison and reference, let's you and I start by looking at the existing DMAIC process forming part of our Lean Six Sigma Masterclass. Here's what it stands for: Define, Measure, Analyse, Improve and Control, where the design phase identifies what the problem is and describes what needs to be improved, because DMAIC is used for existing processes, products or services. The measure then goes on to describe the problem more effectively by gathering facts and data in order to understand how such processes, products or services work and perform. The Analyse step uses those facts and data to determine the root causes of the problem or problems. As you might gather, the Improve is to identify potential solutions to the problem, go on to select the most suitable of those solution options, and then test or pilot it to validate that your choice was indeed the best. Finally, Control is then implement the solution and continue to use data to check the level of performance improvement. So that's DMAIC, and if you want to learn to become a green belt or practitioner level, then do check out our Lean Six Sigma Masterclass. So having stated that, let's now look at what is known as Design for Six Sigma. Get used to this DfSS, that's the way it would normally be written. As I've said at the outset, these 6 video modules are an overview, but act as a companion to our Projex Academy Lean Six Sigma Masterclass. Now, Lean Six Sigma, as I've said, uses the DMAIC method, whereas DfSS uses the DMADV method: Define, Measure, Analyse, Design and Verify. So DMAIC is used to improve existing processes, products or services, but sometimes such a process does not exist. So you need a method to create new processes, products and services. And it may be, for example, that your current process is so poor that scrapping it and starting again makes more sense. So you can design products and services and the processes that support them that will delight your customers, and, as you might imagine, with very high customer involvement from the very start of your project. So DMADV will help introduce new products and services quickly and to a consistently high standard. However, when designing a new product or service, there may not be a customer yet, so instead we focus on the demands of the potential marketplace. Where the customer is involved, this means both end user customers, internal business stakeholders, and the users themselves. So customer requirements and the resulting CTQs, that stands for critical to quality. Again, I go into this in great detail in our Lean Six Sigma Masterclass. These are established early on, and in this case, when designing for Six Sigma, the DMADV framework ensures that these requirements are satisfied in the ultimate final product, service or process that your project will deliver. So as with DMAIC, we manage by facts and not speculation in order to ensure that new designs reflect customers' critical to quality metrics and provide real value to the customers. And if we look to compare both of these methods, DMADV projects are more resource hungry than DMAIC projects in terms of the people involved, IT involvement and cost. However, despite these higher costs and risks, DMADV projects bring higher rewards. Now, in large organizations using Lean Six Sigma, just using a typical example, Let's say 20 DMAIC projects will likely be carried out for every one DMADV project. In other words, DMAIC is more often needed and used because there are likely to be many lean projects and a moderate number of DMAIC projects and a very few DfSS projects as your organisation gradually reduces rework and waste, improves process flow and the reduction of cycle times. Design for Six Sigma often concentrates on the delighter curve in the Kano model. Here's a little graphic here showing you what it looks like, and there's the delighter curve. Again, the Kano model is covered in detail in our Lean Six Sigma masterclass. So DMADV projects are normally used to introduce radical change within an organisation. Here it is going around this loop here. So it is important that you have a change management framework in place in order to address and manage the various people issues that are so important for the successful completion of your project. So there we have it, a nice brief overview in Module 1 of DMAIC and DMADV projects. Here in Module 2, we'll be looking at the DMADV method and in particular looking at the define, measure and analyse phases. So let's make a start right away. Okay, so the D in DMADV is the define phase, and it's here where you scope the project, and it's where the organising and planning of your project actually occurs. So it's where you understand the purpose, rationale and business case, as well as defining what resources you need to help you by giving information and of course to resource the project, along with how you will manage the project. So it's here that you will understand the boundaries, hence scope, of the project, including the processes, markets, customers and stakeholders. It's therefore vital that everyone understands why the project is being undertaken. Now there are two particular tools here which I want to talk about. That is using the affinity diagram and the interrelationship diagrams. These can be very helpful when starting off a design for Six Sigma project. However, these also identify the key areas for project success and bring the team together while at the same time creating an environment and ownership for the team members within the project. Here's a quick snap of an affinity diagram. Again, these and other tools are covered in detail in our Lean Six Sigma masterclass. Affinity, as the name suggests, is really the grouping together areas of common interest. Here, in this simple example, this is all about customer management, product development, customer demands, and so on. Every affinity diagram will naturally choose the way in which these are clustered together. And of course, we can use this to actually prioritize the various critical to quality aspects. So that's the DMADV define phase. The next phase, M, is of course the measure phase. Now, here, the measure phase provides the framework around which the design can be built, and it will be used to make decisions based in further phases. So the focus here is on defining and understanding customer needs and the different customer segments. So design for Six Sigma projects seek to optimize the design of products or services or processes across multiple customer requirements in order that a detailed understanding of all of these can be gained, as this is, as you might imagine, essential. So project needs are translated into measurable characteristics. These are the critical to quality metrics, and it's these that provide for the requirement of the product. It's these that will help define the measures and to set targets while determining critical to quality specification limits of your service or process. I'll remind you again that DMADV is used for creating new products, services or processes. So for those, you must make sure the design can be produced with existing processes, or if they can't, you'll want to design new processes to accommodate such new designs. And if you happen to be already familiar with our Lean Six Sigma masterclass, you need to know for DMADV, process capability is considered in the measure phase, this one, rather than after the design is complete, as would happen in DMAIC. And that brings us nicely to the Analyse phase of DMADV. It's here where the functional specification and high-level designs are developed, and then going on to create and test that detailed design. To help put this in context, it's this analysis phase moves from the what the customer needs to answering questions such as how we might achieve it. So here you'll be mapping the critical to quality elements onto internal functions and looking at alternative design concepts. Now we've got a very important tool coming up which I'll go into a lot more detail on. It's called the House of Quality, also known as Quality Function Deployment. And since that is by far the major tool that's used in DMADV, I'll be going into a reasonable amount of detail on what that is and how it's used. It's interesting because here we are talking about high-level designs. And what do we mean by design? I've gathered two very similar definitions, one from the late great Steve Jobs and the other from James Dyson. Steve's quote was, "Some people think design means how something looks, but if you dig a little deeper, it's really how it works." And James was famous for saying, "Design means how something works," in other words, agreeing with Steve, "not how it looks." And the design should evolve from the function. So if you're using DMADV for a service, the analysis identifies the key functions. But for a more tangible product, for example, then this analysis phase identifies that product's key part characteristics. And as you go deeper into your product or service, the subsystem characteristics are developed next, followed by the components or parts of such a subsystem. We'll see how that is called drill-down in a later module. So staying in the analysis phase, functions are what the product, service or process has to do in order to meet the critical to quality elements identified and specified in the design process. So for a service, functions are key high-level processes that need to be considered, and you will carry out an analysis of the functions to understand their performance capability and to ensure that they're fit for purpose. So the Design for Six Sigma project emphasis is on alternative design concepts and how the generation, analysis and assessment of a high-level design can be carried out. The analysis phase analyzes, as you might expect, and then goes on to select the best design concept and starts to then add more detail to it. And each such design element is considered in turn with the high-level design requirements for each. We're mapping back what we've come up with as a design against the original requirements. And consideration must be given to how each of these components fit and interacts with each other, so that the whole thing can be integrated as a holistic whole solution from your project. Still staying on the analysis phase, this usually creates several high-level designs, going on to assess their suitability and selecting the one with the best fit. So you need to assess performance and develop something called design scorecards. Again, a topic covered in depth in our Lean Six Sigma Masterclass, going on to help analyse how capable the design is to deliver those vital, critical to quality customer metrics. And such assessments from these design scorecards may be carried out through the use of simulations, it might be carried out via field tests, or running pilots that involve the customer in order to capture their feedback. The design scorecard method deploys the requirements into the design and predicts the capability of the new design. So you can see this is a very powerful tool that you'd want to use in a DfSS project. The design scorecard captures the critical performance measures at each level and then go on to visibly track the measured performance as your design evolves throughout the project. And going back to something which you'll have learned right at the start of our Lean Six Sigma course, a common diagram, if you will, for what a process is. And here I'm showing you the balance of measures, because it's important to get these balance of measures and understanding how they each interrelate. Let's check out this diagram. Here it is in a box. This is the process that you're interested in. You have input variables going into this process. This is called the X's. And then you've got the outputs called Y's. And what we'd want to do is we'd want to look at the input X's in terms of the variables and how we're going to measure them. The process X's in terms of the variables and how we're going to measure them. And the output Y's, you've got it, and what the variables are and how we're going to measure them. So the different variables will all need corresponding measures, as I'm showing here, to help you assess the performance. And therefore, to fully understand the performance of your process, you will need a balance of these inputs in-process and output measures with between 1 to 3 measures for each of these. That's the input X's, the process X's, and the output Y's. So your input and in-process variables will influence the results of your output variables. That's what this model is showing, where this can be any process you care to think of. You've got the inputs, the drivers if you will, and then the outputs you get from that process. You can see the outputs would change depending on the process X's and the input X's. So because of this and the influence in the results of your output, your measures should clearly link together. Here we are on Module 3, and we'll be looking again at the DMADV method, but this time looking at the design and verify phases. Also here in Module 3, I'll introduce you to something called the House of Quality, otherwise known as Quality Function Deployment, and we'll be looking at that particular tool for the remaining modules. So let's make a start then, looking at the DMADV design and verify phases. First of all, another tool I want to talk about, known as Failure Mode Effects Analysis, or FMEA. And this is based on the outputs of the review that we looked at in the previous module, and the high-level design requirements can now be finalised and a thorough risk assessment undertaking used using FMEA. So for each of these potential events, known as failure modes, hence the term, you assign a value, usually on a scale of 1 to 10 to reflect the level of risk. So this table shows you the way in which you define which value 1 to 10 for each. A rating of 1 would mean there's no effect on the severity, the probability of it happening is remote, and you could detect it immediately if it occurred. Given a rating of 2, this is for a very minor effect, the probability of this is very low, and it can be found easily. You can get the theme here, I won't go through all of them. Let me just jump into 7, for example. Here the severity of the effect is high, the probability of is high, and it's unlikely to be detected. So as these are getting worse, the detectability moves from seeing it immediately to almost impossible to detect. So a failure mode, therefore, is a mechanism by which the system fails or the process fails. And as you would imagine, a failure mode usually impacts the customer or the business or both. So now let's move on to look at the DMADV design phase. First, thinking about developing the design in the first place. Now, the design phase, therefore, starts by developing the how thinking in more detail, adding this to the various elements of the high-level design that we've already created. So in earlier phases, we defined what the what was, and now we're thinking about how we can design these. So the emphasis here is on developing the designs that will satisfy the critical to quality requirements of the process outputs. Do you remember the X inputs and the Y outputs? And here, the lowest level specification limits, along with control points and measures, are determined, and these form the basis of what's known as the control plan that must be in place following implementation. More of that later. So the design is specified at a level that's detailed enough in order to develop a pilot and then go on to test it. Because before implementation occurs, you need to have piloted this new design. So enough detail should now emerge in order to test and evaluate the capability of the design, and the way you do this is to prepare an effective and realistic pilot here in the design phase. So moving on to the verify phase, here you'll be verifying that the design works. And it's here that the design will be piloted and assessed. And apart, if any adjustments follow the pilot, you'll then go on to implement and deploy it. So the final step in this cycle is to assess the achievements made and the lessons learned. Because these results in the verify phase are verified against those original critical to quality metrics, along with the specifications and targets. So once a solution has been standardized and transferred to its operational area, operations and in-process management, your DMADV project can now be closed. And during handover to the process owner or operational manager, you must work closely with your team to ensure well-planned and well-documented transition. However, in the real world, you may find that you need to choose between DMAIC and DMADV. Indeed, your thoughts at the start may be changed as you progress through the project. So you may start, let's say, using DMAIC improving an existing process, product or service, yet at some point during the project find yourself changing to DMADV. So if that's the case, then let me show you a diagram of the decision points in transitioning from one method to the other. Looks a bit like this. So here's DMAIC at the top and here's DMADV at the bottom. So asking the question, does a process exist? Fairly obvious first question. If the answer is no, then you'll be using DMADV because you'll be developing a new process. If it does exist, then you want to go to the DMAIC route. Another question here is the incremental improvement enough? If it's no, then you need to use DMADV. If it's yes, continue using DMAIC. Third question here is the improvement a new or redesigned product or service? Fairly obviously, if it's yes, you're going to be using DMADV. If no, you're using DMAIC. Okay, and this now brings us to a crucial point in our DMADV overview, and that's the use of a very important tool called Quality Function Deployment, or QFD. Because of the nature of the diagram here, you can see it looks a little like a house, so it's also known as the House of Quality. Now over this and the coming videos, I'll be taking you through the various, as they're called, rooms of the house, including the roof. So although this might look a bit cryptic right now, I've only shown it to you just to give you a flavour of what the thing looks like. We'll now go through each of these in a lot more detail. And here, of course, you need customer research in order to determine the voice of the customer, the critical to quality metrics. And competition research helps us hear the voice of the market and your potential placing within it. So quality functional deployment, or QFD, helps translate both voices, that's the voice of the customer and the voice of the market, into high-level requirements, the CTQs, and to place measurable definitions, specifications and targets on such requirements. So in the analyze and design phases, QFD is further used to develop specifications for the lower level details of this designed new product, service or process, so that high level critical to quality metrics can be satisfied. And here in module 4, 5 and 6, this is the first of 3 videos looking at the House of Quality, also known as Quality Function Deployment, or QFD. So let's make a start right away. Here's the diagram I gave you a picture of in the previous module, again slightly bigger here. This is known as the House of Quality, and what is it? It's a graphical representation of the logical flow, starting from the very start, from identifying your customer requirements, right the way through to the detailed development of actions and activities to ensure that those requirements are met. And just like a child building a small house out of cardboard, you'd want to mark out a big square of cardboard first, something like this, so you can fold it into a house via these various rooms. So the House of Quality is in essence a series of interconnected matrices that are developed starting from moving from the initial requirements through to the design, onwards to the implementation, and ultimately to deployment of your new product, service or process. And this House of Quality is using an example of a small business loan service, which, as I said, we'll work through in the remaining 3 modules. So the House of Quality looks like this as a general model, where we have different room numbers, and these are done in logical flow, starting with room 1, going on to room 2 and so on, that represent the logical flow order for completing the quality function deployment. So here we are, we start with room 1, which is the customer needs, going on to looking at room 2, the competitive comparison and the relevant importance of each of these comparisons. 3, the characteristics and measures, that's stating the how we're going to go about this, the how these CTQs will need to be designed. 4, the relationships, this is the what versus the how. Room 5 looks at competitive benchmarks. Room 6 looks at how important, looking at targets and limits. And finally, room 7 is the correlation, or as you can see it, the roof. So I'm now going to take you through each of these rooms in somewhat more detail. Starting off with room 1. Here's a little graphic there of that picture, and we're looking at this room here. So the first thing you need to do is to identify and segment your customers and go on to build a data collection plan and then to conduct your customer research. So here's the section taken out of that diagram of room 1. captured under what's known as customer needs. Again, to remind you, this is room 1 relative to this small business loan service. Here's the customer needs that have been captured: easy access to capital, low interest rate, quick loan response, and so on. So having found these, you have a fairly good amount of information on the voice of the customer. So you can see here the voice of the customer is what they need and what they're looking for, in this case, in regard to a small business loan. So here you're focusing on organising the information that you have collected and then going on to interpret and translate those into a set of critical to quality statements. Which brings us to room 2. Here we're looking at competitive comparison. So after collecting and completing these critical to quality metrics, which we looked at in the previous slide, their relative importance now needs to be established, where the quality function deployment approach initiates you carrying out a trade-off analysis. So it's here that you will determine which requirements are the most important, so that when you enter the design phase of DMADV, you must understand the priorities from the customer's viewpoint. And also, the customers should be asked to rank you, your organisation, against the competition as part of you organising and prioritising these customer needs. So by ranking you against the competition, this comparison will allow you and your team to determine the relative strengths and weaknesses of your current product, service or process if you have one, with the resulting information being input to the target setting process for critical to quality metrics. So staying on room 2, what you'll now want to do is to assign a symbol for your own organisation and one for each of your competitors, since that's what we're doing here, who should be market leaders or the most distinguished organisations that you compete with. A current topic in the news as I record this is Elon Musk and Tesla and its dominance of the EV or electric vehicle market, and the legacy automakers such as Ford, Volkswagen, General Motors and so on. If they were carrying out a QFD, they'd be choosing Elon Musk here as the benchmarking of the market leader. So for each critical to quality that we looked at in room 1, you need to ask your customers to assign a rating between 1 for the lowest and 5 to the highest for both your company, your organisation, as well as your competitors. And in the house of quality or quality function deployment, this is normally shown similar to this, where the highest rating on the scale is reserved for how the perfect service performs. Here's the customer rating, 1, 2, 3, 4 and 5, that's the scores. And here we've chosen a little shaded triangle for our company, our organisation. One of the competitors here, we've invented a bank called the County Bank, and another for First Union lending. Again, this is just fictitious. So since you're now gathering this competitive information, here's an example of how it might look like in room 2. I think you'd agree that right now our company, whatever that is not actually doing very well. Let's just go back to the detailed picture of the house of quality just to see what we did there. Here it is, you see, here's your priority, here's the competitive comparison, and here that small example I just showed you is now shown in more detail. So what have we done so far? We've looked at our customers' needs and we've prioritised them, and now we're looking to see how we compare against the rest of the world, our competitors, if you will. Okay, and we've simply linked together the symbol for our company so you can see where we currently sit with regard to the rest of the world. So that's room 2. Let's move on to room 3, which is called characteristics and measures, the how, if you will. So here we start moving from the what, which is the competitors we looked at and the scoring of customer needs, to the how of the customer requirements. So far we've only really understood what the customer requires. So it's now we need to understand what characteristics and measures needed to ensure our end design meets or exceeds those requirements. So for each customer attribute, you must therefore determine what characteristics and measures will indicate how well you are meeting their needs. Again, remembering we've captured the customer needs, we've looked how we sit in the competition, we've prioritised them, and we're now in room 3 determining what characteristics and measures we'll need to indicate how well our new process, product or service is meeting such needs. So you will now want to develop these measures for which targets and specification limits can be established. And do remember, again you'll find this in our Lean Six Sigma masterclass, that measurements can produce 2 types of data. that is continuous data. Examples here could be time or temperature, where they could be plotted on a continuous scale, or discrete data, such as accuracy. Alright, there's a good place to stop, because in the next module, Module 5, we'll be continuing our walk through the House of Quality and starting off by looking at Room 4, that is the relationships. Here we are in Module 5, in the penultimate module, Module 5, looking at Design for Six Sigma, and here we'll be continuing our investigation of a tool called House of Quality, also known as Quality Function Deployment. So without more ado, let's get stuck in. So we're now in Room 4, and here Room 4 looks at the relationships. So it's here we carry out some analysis using those critical to quality metrics that were derived from Room 1, going on to use the characteristics and measures described in Room 3, and then start to draw relationships between them. So our purpose here is to ensure that the requirements for each characteristic and measure are taken into account. The way in which you might lay out the relationships, as I'm suggesting here, would be using a scale of 1 to 9, 1 for weak, moderate for 3, and 9 representing a strong relationship. Now do remember, going back to when we looked at Room 1, that concerns the whats, and Room 3, which we looked at in the previous module, concerns the hows. So here in Room 4, we're asking the question, can this how achieve that what? And how do we go about doing that? Well, for each relationship that you identified in Room 1 and the characteristics which you defined in Room 3, you've got to perform the following steps and complete what is known as the relationship matrix here in Room 4. Here's just a snapshot from it. Obviously you'd have a lot more of this in the real world. That here at the first level you've got friendly staff, and from that at the second level, remember looking down at the sub-elements, willingness to answer questions, shows respect, and so on and so forth. And we compare that in this case against the time to answer the phone. So you'd rate each relationship using a scale of strong for 9, medium for 3, weak giving it 1, or if there's no relationship at all, then 0. So you then go on to calculate the score for each cell by multiplying the priority for the customer need that you determined in Room 2 by the relationship score 9, 3, 1 or 0 value of each related cell. So once the relationships have been rated, you then go on to add up the individual scores for each measure, in this case time to answer the phone, and determine their importance. This one has scored 28. And again, to remind you, there would be a lot more rows here. I'm just showing you the principle. So now in Room 4, we have a good understanding of the relationships between the what versus the how. It's time to go into Room 5, which is where we carry out competitive benchmarking, as I've said here. Now, benchmarking is a big topic in itself, and we cover this also in our Lean Six Sigma course. And here I just want to give you a brief overview. So what benchmarking refers to is both looking inside and outside of your own organization and going on to see how well the others are doing at providing products or services that are similar to yours. This is known as performance benchmarking, comparing your product to theirs. But then going on to benchmark processes by looking at how those best practice organizations provide their products and services. Okay, so you've got two types of benchmarking, performance benchmarking and process benchmarking. So you get competitive data for every key measure and analysing it using a 1 to 5 scale. 1 for poor performance, 5 best in class, with a separate row for each 1 to 5 grading. So let's see how that would look in Room 5, competitive benchmarks. Here again, I'm using the same example, showing a black diamond for our company, a square for County Bank, and a circle for First Union Lending. Here's the competitive benchmarks 1 to 5 I've mentioned up here. Here's our company, and here are the others in comparison. So continuing benchmarking in Room 5. For each measure in Room 3, do you remember that? Assign the symbols to the appropriate grading, as I'm showing here. So qualitative benchmarking was done in Room 2, where the customer perceptions of your qualitative performance in relation to the critical to qualities were established. Whereas quantitative benchmarking performance was done in relation to the measures that were established in Room 3. Here, we're looking at actual performance as opposed to perceptions about performance. We can now move into Room 6. And here we're using the results from the previous slide from Room 5 benchmarking. We can now set the goals and targets against the measures and characteristics defined in Room 3. So here we are down here in Room 6. Let me again give you a quick flash of the original diagram so you can get a sense of where these numbers came from. So here's your competitive benchmarks, which you looked at in the previous module, and here are your targets and limits. You can see that each one of these columns relates to each one of these targets and goals from Room 3. So now we're applying those targets and limits in Room 6. Here we've got these targets, each correlating with a different customer needs and the measurements we've chosen for them. So how did we come up with these targets and limits? I've used a range here, some in percentage, others in actual numbers. And frankly, it's a matter of good judgment. You see, setting these targets and specifications really is down to using business know-how and technical expertise of folks along with the use of tools. So there's no absolutes here. This is merely an example of some targets and limits. And something I mentioned in a much earlier module is the Kano Model. So there are two tools used, one of them of which is the Kano Model, and it's used in the analysis of benchmarking data and to gain a good understanding of customer requirements. Here's what it looks like and what you'd have here. Do you remember I mentioned delighters? These are the expectations the customer was not expecting, and delivery quickly satisfies the customer, plus non-delivery has no downside. I remember queuing up in a supermarket once, and it was very busy and there was long tailbacks at each checkout, and the manager came round and gave, I think it was a Mars bar, to each of those waiting in line while apologising. Well, if he hadn't have done that, it wouldn't have necessarily had a downside. I can tell you for one, it absolutely delighted me that someone really cared about me returning and using their service. That chocolate bar brought me back to use that supermarket for the next several years. And then we've got wants. These are the stated requirements from the customer who will be satisfied or dissatisfied in proportion to your achievement. Hence a linear scale here rather than the exponential of being delighted by something unexpected that boosts customer satisfaction. Now, identifying and delivering delighters are business success critical because they innovate and would differentiate you from the competition. Just like that chocolate bar bought my custom for the next several years. Whereas needs are the expected requirements and they are a given. If you don't get needs, then customer satisfaction will not occur. In fact, they'll be dissatisfied. So this is a well-known Kano model, and all I want you to know in this slide is one of the tools we would use in Room 6 when carrying out the analysis of such benchmarking data. Here we are in the final module, Module 6, and here we'll be looking at the final room in the House of Quality or Quality Function Deployment, that is Room 7, and correlation. We'll also be looking at a very important design for Six Sigma tool called the Pugh Matrix. So roll your sleeves up and let's get stuck straight in. Okay, as I said, this is the final room, Room 7, and it's called correlation. What we're doing here is the roof, if you will, of the House of Quality looks at the impact of each of those measures on the critical to quality metrics that we've gathered and how those measures affect each other. That's an important point here. So you first need to examine each measure and then go on to assess the likely impact of either increasing or reducing or hitting the target for each measure on the customer's critical to quality metrics. And don't worry, I'll give you an example shortly. So next you need to examine the relationship between each pair of measures to understand the impact and effects of any relationship on the final design. This will make more sense in a moment. You see, you carry this out by assigning one of these 4 symbols to represent that relationship. We use symbols here simply because fitting the words into the space would make it look too cramped. 2 pluses for strong positive relationship, 1 single plus or add for a positive relationship, a negative, naturally enough, for a negative relationship, and 2 negatives for a strong negative relationship. Here's the roof, and I've made it a bit bigger. There's this point up here so you can clearly see. So this shows how the various characteristics and measures impact the end design, where the objective is to resolve the conflict in situations before, of course, you go on to build that design. So this simply shows the target goals, whether it's increasing or decreasing, or whether it's having no effect at all. Now, in carrying this out, good solutions and designs will not normally require trade-offs, but satisfying negatively correlated measures requires time and forward thinking. So you may or may not need some trade-off between the measures. And the second point here is that conflict resolution should focus on meeting the customer needs, not yours, and therefore measures with a strong positive correlation can become part of your overall design strategy. And that innovation may be required to achieve two apparently conflicting measures, here shown by two plus symbols if you will. Which brings me nicely to developing more houses of quality. I just want you to know that what we're covering, let's say, is this example here over on the left. You might want to drill down into more and more detail and do it in different phases of DMADV. So here this first one developed in measure, this second one drilling down from measure matrix to functions matrix, developing in the analyze phase, drilling down further. Here in the design phase, you're looking at functions and process matrix, and also in the design phase, drill down once more to look at process and task levels. So you can see you could have different levels of detail here for each house of quality. And what this is called is QFD Drill-down. Here's that diagram again. So the aim here is to develop further houses of quality, slowly refining the level of detail until the design is specified at a level that you can go ahead and implement. So moving from one house to the next, you carry over the corresponding targets and importance measures where the number of houses used in drill down may vary, increasing with the level of complexity. So here you've got A and B, here you're taking B and C, here you're taking C and D, and here D and E, and so on. So in the second house of quality, just shown here, developed in the analyze phase, the critical to quality measures and the ratings of the targets and their importance are taken from the first house of quality, as I'm showing here, A, B, B, C. You'll find the correlations to enter the cells by asking the question, if I design this particular function correctly, what impact does it have on my ability to meet the critical to quality measures and targets? And this will then help you identify where the design effort must be concentrated so that you can indeed satisfy the critical to quality metrics, and by doing so, satisfy your customers. So let's now segue from the house of quality to examine the Pugh Matrix. You see, as the quality function deployment house constructions evolve, as shown here, decisions need to be made about the various design concepts and these ideas through the DMADV phases. And what's known as a Pugh Matrix is often used to carry this out. Here's a snapshot of what it looks like, and I'll take you through this if I may. The Pugh Matrix, also known as controlled convergence, is a very clever yet easy to use framework for comparing solutions and concepts against a set of predetermined criteria. But here's the good bit. You see, the matrix helps refine competing designs by improving what's known as the S and negative rankings to a plus and combining the positive attributes into a super alternative. Just look at the little matrix here. This is where you have the concept selection legend, where plus means better, the same means a capital S, and worse is a negative symbol. And what you do is, for each of these, you fill in the relevant symbols. And the Pugh matrix is also used to aid the selection of the best design, and hence is most often used in, naturally enough, design projects. And what makes the Pugh matrix so powerful is it provides a structured way to evaluate alternative or competing concepts, and it benefits from using some scoring which is both non-numeric and iterative. Let me show you. The list selection criteria against which the concepts will be evaluated is absolutely crucial, and you should already have a detailed understanding of customer needs, business and internal stakeholders. So the final list of criteria should be unambiguous and must be agreed upon by the full team. So although it's not always necessary, weighted criteria can be helpful in allowing you to focus on the key concepts. So each row here is an element that you want to consider, and here's your various concepts that you're developing. So you choose one of the concepts as a reference concept, ideally of course something that already exists and represents best in class, going back to my example of Tesla in the EV marketplace, and then compare each concept with the reference scoring, saying if it's better or easier or worse or harder. If the same, then you mark it with an S, as I've suggested up here. Here's a nice big picture of it. For each concept, add up the pluses and minuses and rank them in a preferential order. Very good. That brings us nicely to the end of Projex Academy's overview of the Design for Six Sigma method. If I may, I'd just like to point your eye to where you can find more information on our Lean Six Sigma Master Series, from which this is merely a bonus set of videos, if you will. And this is used for improving existing processes, products or services, hence uses the DMAIC method. And as you might expect, our Lean Six Sigma Master Series has been designed to fully prepare you for the Greenbelt Practitioner exam. If you'd like to find out more information, and I encourage you to do so, hop on over to our website www.projex.com/courses/Lean-Six-Sigma-Masterclass. Or simply just turn up at projex.com and select the courses menu from the top of the page. And in case you didn't know, we have a full access membership pass for all of our courses, including this one, where you get 12 months access to well over 30 of project management and general management video-based masterclasses. So looking forward to your company at some point in the future. For me, Dave, it's bye for now.